Right, the function f has domain 0, infinity, and is defined by this here. Show that f dash of x is always positive. Okay. Now, it is important to realize that that is f dash there, right? It's not f to the minus 1, it's f dash. And remember, f dash, you need to do dy dx, right? Okay, that is the same as f dash of x, right? It means the same thing. So you've got to differentiate. And yeah, you will occasionally get a question on functions where they ask you to differentiate first, and there is a reason for it. So if we take f of x here, as it is, now what I would do is, because I want to differentiate, is I will take that bottom bracket, if you like, up and put it to the minus 1. It's much easier to differentiate then. So I'll do dy dx, or f dash of x. And when you differentiate 1, it's 0, it goes. Differentiate this, remember now function of a function, C3 work, bring the minus 1 down, times it by the minus 2, so that becomes plus 2, bracket 3x squared plus 2, and then take away power, so you get minus 2, and then you've got to times it by the derivative in here, which is 6x. So we end up having 12x on the here, and then 3x squared plus 2 to the minus 2. Now what I would do is, I would then rewrite it, so you've got 12x on the top, 3x squared plus 2 all squared on the bottom. So we need to show this is always positive, and this is what we've got. Okay, maybe you were hoping that it would come out to be like a positive whole number, you know, so if it came out to be 8 or something, you could say that there you go, it's positive. But that doesn't usually happen, okay? We can still show it's positive though, because if you think about it, we're looking at f of x here, right? And look, they've told us what the domain is. Yeah, the domain is positive. Okay, so the domain of f is 0, infinity. So i.e. x is positive, right? Now if x is positive, think about it, 12x will be positive, won't it? Okay, so we say therefore, if x is positive, 12x is positive. You're just timesing it by 12. It's going to make it even more positive. The bottom will also be positive because you're squaring. Okay? Okay? Right, the square of anything is always positive. Always positive. So, we've got positive on the top, positive on the bottom, positive divided by the positive is positive. So we've proven that f dash of x is positive. Now you might be wondering, you know, why have they asked us to differentiate in a function question? And there's a very good reason, okay? And the reason being is this graph here, I haven't got a clue what it looks like, okay? Some functions we just don't know what they look like. In other graphs, we know what they look like. We know quadratic, for instance, smiley face and so on. There's lots of graphs we do know, but I don't know what this looks like. So when it comes to part B then, working out the range, I need to understand this idea here. If f dash of x is always positive, what that's telling me, of course, if you remember, dy dx, the gradient is always positive. In other words, this graph is always increasing, if you think about it. If dy dx is always a plus, the gradient, yeah, is always a plus. In other words, it's going up all the time. So your graph is constantly increasing. Okay, I don't know what it looks like, but it's, you know, as x increases, it will constantly increase. Okay, it will never dip. It will never go that way. That's not going to happen, because then we'd have negative gradient, wouldn't we? So that's not going to happen. We know it's constantly going to increase. And what's good about that then is, if we know that that's the case, constantly increasing, we can take the lowest value in the domain, okay, and that will give us the lowest value in the range. Okay, and the same here, we can take the highest value in the domain, okay, which is up here, okay, the highest value in the domain, which will be over here somewhere on the x-axis, and that will give us the highest value in the range. In other words, we can take this, we can be confident, we can take this domain to get us a range. Okay, so we got the domain is 0, infinity. Okay, and our function, I'll write it down here again, is this. So we can put then 0 in. 0 goes to 1 minus 2 over 3 times 1 plus 2. Okay. Oh, sorry, 0 there, isn't it? That's what I want there. and that comes out to be 0 if we work that out. Okay, and if we put infinity in, 1 take away 2 over 3 times infinity squared plus 2. Okay, now you divide it by a massive number, this is going to go to 0, isn't it? So that's going to end up going to 1. Alright, so your range would then be 0, which is 0 included? No, it's not. And 1 certainly isn't included, because that's from the infinity. Okay, as x goes to infinity. So there is your range, right? So you might have a graph, something like that. And going back to the idea again, right? Going back to the idea again, that quite simply, because it's an increasing gradient, always positive, you know the lowest value in the domain will give you the lowest value in the range, and then the highest value in the domain will give you the highest value in the range. Part C, then find an expression for the inverse. So if I rewrite it as this here, 1 take away 2 over 3x squared plus 2. Okay, now here we can be sort of clever with this, right? Double check I've done that right. Yeah, we can be clever with this. You could take that y over, it becomes minus 1. But what I take that 1 over, sorry, it becomes minus 1. But what I would do here is, because we got minus this, because that is a minus, let's take all of this over the other side. Okay, and then take the y over that side. So the y over that side becomes minus y. Take this all over, it becomes positive. Then I'm going to swap these two. Okay. Then I'm going to get x, remember, so I'm going to take the 2 over. Okay. Then I'm going to take the 3 over and divide. Now I could divide the whole thing by 3, but better if I just write it as a third. It's just a bit neater, isn't it? Okay. And then to get x, I need a square root, and square root goes plus or minus. Okay, I get that. And we need to decide whether it's positive or negative. Now I need to remind myself of the domain again. Domain is positive, isn't it? 0 infinity. So we say take positive root because domain. And it's important you put this reason down, right? Domain of f is positive. So therefore, f to the minus 1 of x is this. Okay? You might have a variation, you might have done this and a quite slight variation of it where the signs are slightly different, but you could still get it spot on, right? It just depends how you rearrange it up here. So the domain and range then, well, the range we know is 0 infinity, because that's the same as the domain of f, and then the range we worked out to be 0, 1, so the domain is going to be 0, 1. And we've answered our question.